back to the channel. If you watched my previous video, I hope that you're as convinced as I am that a Navy in space is just around the corner. That said, the first video left out a hugely important reason why this will happen sooner than later: cost. In this video, we'll talk about the resources needed to get to space, and why it just may be the most important factor of all in the deployment of the US Space Navy. Why? Well, this video will show that a fully capable maneuver asset based on Space's Starship for the Department of Defense and its US Space Force could literally cost less than an atmospheric 5th generation fighter plane. Impossible? Not anymore. Strap yourselves in for the latest installment in the story of the US Space Navy. I mentioned in an earlier video that cost per kilo is the coin of the realm in the world of space travel. That's the amount it costs to place a kilogram of mass in orbit, and it's long been the limiting factor in our movement to space. As little as 10 years ago, the cost to place a single kilo of cargo into low Earth orbit, or LEO, ran into the tens, even hundreds of thousands of dollars. Launch costs for competing rockets are readily available, and they've always been the reason that getting to space is so expensive. As this graphic illustrates, cost per kilo varies wildly, with some vehicles, like the Space Shuttle, generating a far greater cost for movement to orbit than other rockets. This graphic also shows a significant decrease in the cost per kilo to orbit over time, courtesy of SpaceX's Falcon 9 and Falcon Heavy rockets. What this graphic doesn't show is the projected cost per kilo for Starship. Yep, that's right, $66 per kilo. That's an estimate, but even if the SpaceX engineers are off by an order of magnitude, it will still be completely groundbreaking. How is this possible? Well, the biggest reason? Miracle number one: reusability. Starship will not only be the most powerful rocket ever to go into service by an order of magnitude, it'll also be 100% reusable. That revolutionary fact, coupled with drastically reduced manufacturing and component costs, is what gets you to the $66 per kilo figure. I should note that we'll be talking about three interrelated miracles in this video: reusability, component costs, and manufacturing speed. All three are important. Taken together, they are transformational in the fullest extent of that word. Honestly, miracle number one doesn't seem so miraculous anymore, what with SpaceX landing its Falcon 9 rockets routinely. That said, landing something larger than the Saturn V moon rocket should give anyone pause. Even crazier, SpaceX intends to catch the booster in the Starship in midair, saving inevitable wear and tear and damage to landing legs that occurs when you use the traditional approach. This effort is in progress, with the first attempt to actually complete the procedure scheduled for the next flight test sometime in August. It's about to get even crazier, but before we continue, please like and subscribe to the channel. I'll be bringing you a lot more defense-focused space content in the very near future. The whole cost per kilo to orbit issue has been with us for as long as we've been traveling to space, and a fully reusable Starship certainly seems poised to dramatically reduce that burden. That said, you still have to build a huge and expensive rocket to start with, and that's where the second miracle occurs. SpaceX has driven the key costs associated with rocket manufacture down dramatically. How dramatic? Two elements in particular are at the center of SpaceX's cost-cutting efforts: engines and basic fabrication materials. As this image shows, SpaceX has been able to decrease its engine manufacturing costs to a point as much as 99% cheaper than comparable engines at Rocketdyne and Blue Origin. Indeed, SpaceX is able to equip its Super Heavy booster and Starship second stage with 39 of its engines for about the cost of a single Blue Origin BE-4 engine. Don't even get me started on the Rocketdyne product. NASA paid $1.79 billion for the latest 18 Rocketdyne SLS engines, setting their unit cost at about $100 million each. The second element, rolled steel, was not chosen as a cost-cutting measure, but it certainly doesn't look that way on the balance sheet. While steel is far easier to work with than carbon fiber, and withstands the heat of re-entry far better than the alternatives, it also just happens to be roughly $130 per kilo cheaper than carbon fiber. That translates into another 90% reduction in costs relative to the alternatives. So that's the second miracle. Amazingly, these costs can be expected to continue to decrease as SpaceX iterates its design on a continuous basis, which could also be called miraculous as well, but I digress. The third miracle is at least as important as the first two, because labor costs play a much larger role in rocket manufacture than you might think. As this chart shows, labor costs for a rocket build are based on the size of the workforce and the time required to manufacture the rocket. Space Launch System currently spends roughly $400 million a year paying its 5,000 employee workforce. Worse, the time between flights, which can reasonably be attributed to building and testing the next rocket, is currently at 35 months. So that's roughly $1.2 billion in labor costs to build the next SLS. And this is where the third miracle comes in, with SpaceX projecting the ability to manufacture a complete rocket every 3 days. Looking at the image, you'll note that I used 9 days for the calculation, because SpaceX literally never sleeps. Star Factory operates 24 hours a day, 7 days a week, as opposed to the other guys who clock in at 8 and out at 4. All of this translates into a massive reduction in the labor costs relative to any other aerospace company.
We have liftoff.
As this graphic shows, the flyaway cost of a complete Starship with Super Heavy booster costs out at roughly $64.5 million. Even better, a purchaser could opt to use SpaceX launch services and forego the booster cost, putting the flyaway cost for the Starship second stage at less than $35 million, with launch services adding less than $5 million additional, because the customer is only paying for pad services and fuel. It's reusable, remember? Starship's extreme low cost will drive a huge shift in thinking within the DoD generally, and the Space Force in particular. As a part of the larger Air Force, at least from a budget perspective, Space Force funding has pretty much been limited to satellite operations. The creation of an affordable space maneuver platform will change that reality completely. Starship will result in a drive for manned orbital maneuver capability that will be irresistible given the operational and strategic advantages that it affords. In practical terms, the development of Starship means the availability of a fully functional, deployed maneuver asset costing less than a single F-22 or F-35 fighter does today. Let that sink in. The Space Force will be positioned to deploy multiple maneuver platforms for less than a single squadron of 6th generation fighters, and the delta in combat capability will literally be incalculable. Stay tuned. In our next episode, we'll explore the nuts and bolts of how the United States Space Force, the USSF, might deploy its first true maneuver formations in space. We'll discuss how such a force might be manned, trained, and equipped to control the high ground in the decades ahead.